All right, so last thing we did today is we were looking at an APFR2 that had to do with the block sliding up and then down the ramp. There was friction, and the question was, well, how's the motion of the block different sliding up versus sliding down? So here's each free body diagram. It has the same weight, has the same normal force, which is the cosine component of the weight. Okay, nothing crazy going on. Okay. But most importantly for the free body diagram is that the direction of the friction changes. Now, friction is coefficient of friction times normal force. That's the magnitude. Okay. But if it's sliding up the ramp, then friction is down. If it's sliding down the ramp, then friction is pointed back the other way. It's always opposite of motion. Okay. And that changes the net force on the block because sliding up the block, sliding up the incline, the friction force and the sine component of the weight were acting together, so create a huge net force. Versus when the block is sliding back down, well, now these two guys, the sine component of the weight that's trying to make it slide down is opposite of the friction. So the net effect is that there's a very tiny net force. If there's a tiny net force, that means there's much less acceleration, which means that the block takes a long, long time to slide down, and also its average velocity would be much less, and its final speed at the bottom would be much less than what it had been kickstarted with over here. So that is a summary of that FRQ.